ComFloor is a composite steel floor decking, ideally suited to modern high-rise structures. Available in both shallow and deep decks, the ComFloor range represents some of the most economical floor solutions and is arguably the most efficient choice of profile currently available anywhere in the world.
A composite floor is one in which the steel deck mechanically bonds with the concrete topping, so that the steel and the concrete work together to form the floor structure. The technology reached the UK at a time when the concrete had a dominant three-quarter of the market for multi-story building. The introduction of steel profile using composite slab technology changed the market forever. And today, 70% of multi-story buildings are steel framed. The principal benefits of building with composite steel flooring system are increased speed of construction. The deck instantly acts as working platform. Construction stage bracing, providing diaphragm action to the floor. Reduction in the weight of the floor. Overall building height reductions. Inherent fire safety property. And the simplicity of attaching building services. Circular embossment in particular reduces the amount of distortion created during the rolling of the deck. This later leads to reducing residual stresses within the profile, which help the flatness of the deck. The embossment, along with the round edges, increases shear bond action between the deck and the concrete slab, and has led to increase in the M&K value found from the test that was carried out here at Imperial College. As with any construction product, this decking are tested to European standards. Eurocode 3 for cold form steel and Eurocode 4 for composite slab and beams.
The ComFloor 80 and the ComFloor 60 profiles were designed to span further in the unpropped condition over any other profiles in the world. Having a profile that spans further is only half the story though, because in floor areas where the spans are not so important, it means the gauge thickness can be reduced. Smaller gauge thicknesses means that the overall floor cost can be dramatically reduced. Deck design is not an exact science, however, one of the key areas for the design of these profiles is to try and ensure that the cross-section of the profile is fully effective. The introduction of the large corner radii is to reduce the individual element lengths of the compression zone of the profile. The CF60 and the CF80 are circular embossments. The purpose of these circular embossments is to ensure that the concrete works with the decking. They put less stress into the profile, which actually means that there's no twisting of the profile. So when it's laid in situ, the decking actually sits firmly onto the top flange of the beam. When you look at the cross-section of these new profiles, you'll notice that the bottom stiffeners in the trough have actually been pushed apart, as opposed to a traditional central stiffener. By doing this, the shear stud connector can be placed centrally within the trough, and this means that the stud will achieve its full capacity.
ComFloor decking will span further than any other flooring deck profile. In the double span condition, ComFloor can span in the region of 4.5 to 5 metres without the need to prop. In a typical grid structure, traditional composite decks require a greater frequency of beams. The use of ComFloor can reduce the number of components by as much as 25%. Let's consider a typical crest configuration with a central stiffener. As the horizontal elements will at some point be in compression, it is important to keep the individual B/T ratios for these elements to a minimum. The location of the shear stud connector within the deck profile is of paramount importance. The latest ComFloor profiles only allow the studs to be centrally placed, which is the optimum position for developing the stud capacity. Extensive testing and fire engineering work have resulted in fire ratings of up to 4 hours when using a light mesh within the composite slab and no protection to the deck.
We are proud that we have a very high quality controlled manufacturing process. At the beginning of each order, then at regular intervals, quality checks are carried out on the ComFloor. Only once these checks are satisfied will production continue. ComFloor has gained great favour since the launch of ComFloor 80 in 2004, with hundreds of thousands of square metres supplied all over the globe, and demand only growing. The world realises the great benefits of the ComFloor composite floor system.
Essentially, it starts when we got our steel frame erected, and obviously we hang safety netting beneath the floor where we want to be working. The steel composite panels actually come in bundles on the back of a flatbed and lifted onto site by crane, and typically then we take from these bundles of, say, 15 sheets, they're actually placed in position and then fixed to the beams. Once the deck is then laid in position, it becomes a working platform, but also is a crash deck, and so allowing work to carry on unimpeded on the levels below. The shear studs are then taken and placed in position through deck welded onto the composite beams. The steel mesh is then laid, concrete poured, and then it's finished.
Comfloor is a high-quality composite decking product, manufactured with tight controls on testing and packaging. It has been proven to provide significant savings in both construction time and overall structural costs in buildings all around the world.
Comfloor 210 was introduced to the New Zealand market in 2002 and has been used in the United Kingdom for over 20 years. Comfloor 210 is best used in a single span configuration where the 210mm deep profile is fully or partially incorporated within the height of the supporting beam, resulting in a reduced story-to-story height when compared to using metal deck laid directly on top of the beam. Comfloor 210 is very economical in terms of concrete volumes used. This is due to the deep beam-type troughs that provide the spanning strength, while the broad top of the profile minimises the amount of concrete used overall. Comfloor 210 suits construction that requires large spans, but also demands a thin overall floor system, that is the total floor system height inclusive of the beam. Comfloor 210 has the longest unpropped spanning ability, over 5-metre beam centres. When temporary propping is used, spans of over 8.5 metres are possible. Comfloor 80 was introduced to the New Zealand market in 2005 and has been used in the United Kingdom since 2004. Comfloor 80 is best used where long sheets continue over multiple beams to fully utilise the fantastic spanning capabilities and construction bracing properties of Comfloor 80. And as such, it suits high-rise construction and where a simple, large spanning and lightweight flooring system is required. Comfloor 80 is a great balance between economic concrete use and robust acoustic and fire performance, achieving 4 hours in fire testing without any modifications to the underside of the decking. Comfloor 80 can span unpropped to over 4.6 metre beam centres. When temporary propping is used, spans up to 7 metres are possible, meaning Comfloor 80 is a great all-round choice for your project. Comfloor 60 was introduced to the New Zealand market in 2008. Comfloor 60 is similar in use to Comfloor 80, but is better suited when the thinnest possible slab is required or where acoustic, fire and vibration criteria are critical factors in the design. Using less material width than its manufacture, Comfloor 60 also comes at a lower unit cost than the Comfloor 80. Comfloor 60 is great for commercial car parks and storage units, or anywhere a long-spanning, concrete-efficient slab is desired with good solid performance characteristics. Comfloor 60 can span unpropped to over 4-metre beam centres. When temporary propping is used, spans up to 7 metres are possible. The Comfloor range has many uses and can be used to good effect on virtually any substructure desired. The structure best suited to Comfloor, however, is structural steel. Structural steel combined with ComFloor saves weight, which gives huge benefits to foundation design and overall beam and column sizes. ComFloor combined with structural steel speeds up the construction time, with a poured floor-to-floor turnaround sequence of 5 days not uncommon. This can save months of construction time compared to other styles of construction, leading to faster occupancy and return on investment. When used unpropped, services and other fit-out installations can proceed unhindered immediately after the ComFloor sheets are installed. Although structural steel is the best option, other support structures commonly used are masonry, precast units such as shell beams, and even in situ poured beams can be used to support ComFloor. ComFloor can be used propped or unpropped during construction. It's best to construct unpropped either as single-span sheets or as continuous sheets. A single-span design can be improved by approximately ½ a metre when continuous sheets are used, reducing the number of beams and saving the project unnecessary costs and construction time. If maximum spans are wanted from the ComFloor slab in service, propped construction can be used. Spans of 7 metres can comfortably be achieved, with spans over 8.5 metres possible. So within the ComFloor range, there is a product that will suit any application. ComFloor is a great balance between strength to support the wet concrete load, unpropped up to 5 metres, and lightness, with 2 people able to handle the longest lengths. The route to market for ComFloor is through Composite Floor Decks Limited. Nationwide, they can supply direct for self-install, or their specialty, a fully installed option including installation of decking, shear studs and edge trimming, ready for the placement of reinforcing and concrete. Composite Floor Decks Limited work professionally to achieve the project's time and safety targets. Unique to Composite Floor Decks Limited is the use of safety netting. This provides a physical barrier for both people falling from the structure and workers below are protected from objects falling from above. The netting also allows workers to move freely about untethered, speeding up the construction process. For more details on their offer, visit them at www.studwelders.co.nz. Alternatively, ComFloor can be installed by anyone with suitable building experience. An overview of the installation process follows. For details not covered within this presentation, please refer to the relevant ComFloor product brochure. These are available for downloading at www.comfloor.co.nz. There are 2 fundamental points to always keep in mind with regards to installing ComFloor, that if overlooked can cause safety and performance problems. Prop first. If used, temporary propping is best installed prior to laying the ComFloor sheets. Note, however, if using Composite Floor Decks Limited for installation, the temporary propping will interfere with the placement of the safety netting they use. Please contact Composite Floor Decks Limited in this instance. They'll advise if propping can be safely omitted during the ComFloor installation stage, as often it's required during the concreting phase only. Never cut sheets. ComFloor must never be cut shorter than that supplied or specified on the drawings, without first consulting a ComFloor representative. Cutting will reduce the spanning ability of the ComFloor and may lead to larger deflections during the pour or actual sheet failure under load. And never cut ComFloor mid-span under any circumstances. ComFloor 60 and ComFloor 80 are installed in exactly the same manner. The ComFloor 210 installation process differs, however, and is addressed separately within this presentation. The strip end cap is most often used and is installed before the ComFloor is laid. For best results when using the strip end cap, the supporting surface should be smooth and free of debris. ComFloor strip end caps are fitted flush to the inside face of the beam or concrete. Fixings are at third points, located so they don't interfere with the seating of the ComFloor sheets. A great benefit of the end cap strip is that they act as a set-out template for the ComFloor, negating the need for coverage or out-of-square checks otherwise required. The singular end caps are fitted after the ComFloor sheets are installed. They are cut from ComFloor closure angles, supplied in 2.4 metre lengths bundled together. Bundles are cut on site into 200mm lengths using a metal-rated cutting disc. Masonry blocks must be solid-filled and developed structural strength before laying and pouring the ComFloor. Care is also required to ensure the grout is smoothed off, providing a flat surface for fixings, and the reinforcing bars do not clash with the ComFloor seating area. Fix the ComFloor into the grout to avoid unsightly damage to the blockwork. For best results in masonry, pre-drill and hammer in masonry anchors, one fixing per sheet. Although less is possible, it's recommended the minimum seating for both the side and end of the ComFloor sheet is 50mm onto steel and 70mm onto masonry. This serves both as an additional safety factor, but more importantly avoids the need for precise measuring during installation. The first ComFloor sheet is always laid with the overlap edge facing the starting point. ComFloor must be fixed to the permanent structure along the side lap at a maximum of 1 metre centres. As each sheet is laid, it is fixed to the permanent support, one fixing per sheet. Please ensure that the drive pins fixing the sheet do not clash with any future shear stud placements. An ideal location is at the base of the rib upstand as shown here. They are then TEC screwed together through every second pre-punched hole, resulting in fixing at no more than 1 metre centres. Often shear studs are used to create a composite design, meaning a much smaller beam can be used than for a gravity beam design. Shear studs are best installed in a through deck fashion. That is, studs are welded on site after the ComFloor is installed. This results in a faster installation sequence, and the ComFloor sheets act as a bracing diaphragm to the structural steel during the construction phase. The top flange of the steel beam must be unpainted and free from dirt, debris and moisture to ensure an effective weld is achieved. ComFloor 210 is typically installed as a single span only. That is, the sheets tend to span beam to beam or wall to wall, and not over the top of multiple beams or walls, as is best practice for ComFloor 60 and ComFloor 80. To fully utilise the benefits of ComFloor 210, it's usually incorporated within the height of an asymmetric beam support system, thereby reducing overall story height. Numerous beam configurations are possible with ComFloor 210. For best results, contact your ComFloor representative and discuss your project's needs. Asymmetric beams focus the tensile capacity towards the bottom of the beam, maximising performance while keeping the overall floor height to a minimum. Fabricated asymmetric beams can currently be sourced from Steltec, Cellbeam and Fabsec. When installing ComFloor 210, the end support diaphragms are always used and are installed first, as they're a vital structural component that supports and maintains the correct shape of the ComFloor 210 under construction loading. The ComFloor 210 end support diaphragms are fixed down at third points so as not to interfere with the seating of the ComFloor sheets. Please note the orientation of the end support diaphragm, as this will affect installation if not correct. The first sheet of ComFloor 210 must be laid so the edge with the punched holes faces the starting point. The edge lap is fixed at 600mm centres with heavy-duty drive pins. Subsequent sheets are then placed down on the preceding one, so the pre-punched holes are always visible from above. As each sheet is installed, they are Tech screwed into the top flap of the end support diaphragm. For spans under 6.5 metres, all sheets can be laid before any side lap fixings are installed. For sheets over 6.5 metres, one shear bond clip is Tech screwed at mid-span as each sheet is installed. This ensures worker safety and sheet integrity during the installation sequence. Once all sheets are installed, the ComFloor 210 is fixed to the beam through every trough with heavy-duty drive pins. And shear bond clips are fixed at 350mm centres, that is through every pre-punched hole. ComFloor 210 requires a reinforcing bar in every trough to achieve the required shear bond characteristics, the size of which is determined by the ComFloor design software. The rebar is held in position using a standard 100mm circular spacer. Placement of mesh completes the basic ComFloor slab and is now ready for the concrete. The minimum end seating for ComFloor 210 is 50mm, but to facilitate installation tools, concrete flow and vibrator access, a 75mm shelf should be provided. This is to ensure a 25mm clear vertical access zone is available between the top flange of the beam and the ComFloor sheet. Where this is impractical, the top of the ComFloor can be cut out locally, but care is needed to avoid cutting the end support diaphragm. This extra cutting work should always be itemised and allowed for when seeking quotes or pricing any ComFloor 210 installation. There are several specialised accessories available for ComFloor. Closure plate is used where the 600mm cover width of ComFloor doesn't quite fit the structure. Closure plate can be used for gaps up to 140mm edge to edge. Alternatively, the ComFloor sheets can be split and spliced back together. In both cases, Tech screws at 300mm centres must be installed to maintain the structural integrity of the splice. Closure strip is used to block the ComFloor sheet ends to stop concrete escaping. Supplied in 2.4 metre lengths, it's cut to create single end caps, 200mm wide for ComFloor cut square. For curves and angle cuts, the closure strip is cut to suit. It's never installed as a solid strip. For ease when forming the slab edges, use the ComFloor edge trim available for any slab thickness. ComFloor edge trim is fixed either to the steel beam or to the ComFloor itself. Restraint straps at 600mm centres stabilise the edge trim against concrete load. Consideration should be given to the installation of any perimeter reinforcing. Often this needs to be installed prior to the restraint straps to avoid rework. Edge trim must never be stepped upon. It's designed for horizontal loading only. The construction joint former matches the shape of ComFloor 60 and ComFloor 80 and is designed to reduce concrete seepage when forming construction joints or when forming voids that will be cut out after the concrete pour. Timber backing is used to form the slab height and provide horizontal stiffness. The ComFloor construction joint former can easily accommodate bottom reinforcing, will not interfere with mesh placement and is fixed to the top of the dovetail portion of the ComFloor. ComFloor hangers are available for ComFloor 60 and ComFloor 80 only. The ComFloor threaded wedge nut is best used for heavier loads. For loads up to 50 kilograms, a GTD type hanger can be used. Threaded rod and terminal fittings are typically supplied by those